Hey everybody, so in this video we're talking about proving the quadratic formula. So if you have not used the quadratic formula before, it is a formula that will always give you the roots of a quadratic expression, just like completing the square. But there's a reason quadratic formula works, and we're going to show you that in this video. So what we're going to do is we're going to go through the steps of completing the square on the standard form of a quadratic equation. So remember, the first step with completing the square was to move the c term. So here I can subtract c. Now I have ax squared plus bx equals negative c. And now we know that completing the square will only work if the leading coefficient is 1. Well, here we don't know what it is. It's a. A could be any number. So we want to ensure that it has a coefficient of 1. So what I'll do is I'll divide everything by my leading coefficient. So here I will divide everything by a. And now I have x squared plus b over a x equals negative c over a. And now, during the part of completing the square, we would know that in order for this to be a perfect square trinomial, I have to take whatever this value is, cut it in half, and square it. And that's what this value should be. So that's what we're going to do here. We're going to take this expression and cut it in half. So when you cut something in half, that's the same thing as multiplying by 1/2. So here I'll have b over a times 1/2, and this gives me b over 2a. This is the value that I will square. Now, when you square something, be careful, because you'll think here, oh, this is just b squared over 4a, okay? And it's easy sometimes to make small mistakes when you try distributing like this. Remember, when you square something, that's multiplying something by itself. So this is the same thing as b over 2a times b over 2a. b times b is going to give us b squared. 2a times 2a is 4a squared. This is what I'm going to add to both sides. So now I have plus b squared over 4a squared plus b squared over 4a squared. Now, I'm going to take this and I'm just going to rewrite it right up here. So here I have x squared plus b over a x plus b squared over 4a squared equals, and then here I'm going to rewrite this to be b squared over 4a squared minus c over a. The only reason I'm doing that is because you've learned that when you work with polynomials, you want them in what's called descending order, so you want the highest exponent first. So that's really all I'm doing. So here I have b squared minus 4a squared minus c over a. Now, here we want this trinomial to be equal to one term. Here I have two terms because I have b squared over 4a squared minus c over a. So here I'm just going to subtract these two fractions. Now, when you subtract, you have to remember you need common denominators. Here I have a 4a squared. Here I have just a. So I need to think, what do I need to multiply a by so that I get 4a squared? And I need to multiply by 4a. So here I'll multiply by 4a on top, 4a on bottom. And this will give me 4a squared in my denominator and 4ac in the numerator. So here I now have b squared over 4a squared minus 4ac all over 4a squared. And now, since my denominators are the same, I can write this as one fraction. So here I have b squared minus 4ac, and this is all over 4a squared. Now, here, what we're going to do is we're going to go ahead and come down here and we're going to factor this perfect square trinomial. So if you remember, it will always be the value once you cut the middle term in half. That's what's going to go in your parentheses. So here I have x plus b over 2a quantity squared. Now, let's think about this. B over 2a times b over 2a, that gives me the b squared over 4a squared. B over 2a plus b over 2a, that gives me b over a, right? Because 1/2 plus 1/2 is a whole. So now here I can solve by taking the square roots. So now I have x plus b over 2a equals, now you may not have worked with something like this before. That's fine. The rules are still the same. When you take the square root of a fraction, you take the square root of the numerator and the denominator. I cannot take the square root of this. I have no idea what these values are. So here I'm going to say plus or minus the square root of b squared minus 4ac all over. I can, however, take the square root of 4a squared. That's going to be 2a. And now I can solve for x by subtracting b over 2a. So x here equals, and now look at this, b over 2a. This is the square root of b squared minus 4ac all over 2a. My denominators are the same, so I can write it as one fraction. So it's negative b plus or minus the square root of b squared minus 4ac, and this will all be over 2a. And there you have your quadratic formula. That's where it comes from. This is why the quadratic formula works. It is essentially the shortcut to completing the square. I took the standard form of quadratic, I did all the steps for completing the square, and I got the quadratic formula. This is very important now because when I'm working on quadratics, I can use completing the square if I want to, or I can just take the values of a, b, and c, plug them into my quadratic formula, and I'll get the solutions. And that's what we're going to talk about in the next video. All right, I hope that you found this helpful. If you have any questions, please leave them in the comments, and we'll see you all in the next video.